students from the stats class. The probability of a student being male is 0.25. What is the probability that exactly 5 are male, at least 8 are male, more than 8 are male, at most 2 are male, less than 2 are male, and at least 2 are male? So we'll see how do we tackle each and every one of these scenarios. These are the keywords that we need to keep in mind when approaching each and every one of these. Okay, so what is the first question asking us for? Is looking for the probability if we have exactly 5 boys from the 10 boys that are coming. Okay, so with exactly, you just plug your values into your equation. So you can identify your values before approaching the question. We know that our n is 10 because that's how many variables we'll be checking. Our possibility is 0.25 is equals to 1 minus 0.25, which is equals to 0.75. So x is a changing variable, so it will depend on the question. In this case, the first question, it being 5, because the probability that x is equals to 5. So you just simply plug each of these things into our equation that we saw from the previous videos. This will be 10 factorial over 5 factorial times 10 minus 5 factorial times probability of a success, 0.25, to the power of the number of successes, which is 5, times the probability of a failure to the power of the number of fails that we have, which is 5 as well. You can put all these in brackets to avoid any errors on your calculator, and this should give you 0.0584. So this is the simplest form of this question that you'll always find, and we'll see as we proceed that the questions get more trickier. Okay, in our second example, they're asking us what's the probability that at least 8 are male. So when presented with a problem like this, you know that at least means 8 or more. So 8 can either equal, x can either equal 8, 9, or 10, because that's your largest number, 10. So this can be split into all 3 possibilities, which is 8, 9, and 10. And then each of them, you apply the same formula you applied for exactly. So you find exactly 8, exactly 9, and exactly 10, and you add them up, and you have for at least 8. So this will just be, this can be simplified, the first part of this equation can be simplified into just from 10, choose 8, times the probability of success, which is 0.25, to the number of success you have, 8, times 0.75 to the 2, plus 10, choose 9, 0.25 to the 9, times 0.75 to the 1, plus the last one, 10, choose 10, times 0.25 to the 10, times 0.75 to the 0. Okay, so each of these will give you individually 0.000386 plus 0.0002861 plus the last one, 0.000009537, and altogether that should give you 0.000416. Okay, and that's your probability of x equaling greater than 8. So our next question will ask us, what is the probability that x is more than 8? This one does not include 8, meaning you'll only be summing your 9 and your 10. And in this case, after we already have them from the previous question, they should give you a total of 0.0000296. Be very careful as to whether they say more than or at least. Okay. Now we're looking for where x is either less than or equals to 2, and it's at most in other case. So probability where x is less than or equals to 2. So these include 3 possibilities where x is equals to 0, plus probability where x is equals to 1, plus probability where x is equals to 2. And you apply the same formula. So basically, from question to question, you'll notice that it's just a matter of applying what your inequality means. In this case, it's less than 2. So you will know that the only values that are less than or equal to 2 are 0, 1, and 2. So for the same for this, 10 choose 0 times 0.25 to the 0 times 0.75 to the 10 plus 10 choose 1 times 0.25 to the 1, 0.75 to the 9 plus 10 choose 2 times 0.25 to the 2 times 0.75 to the 8. So each of those should give you 0.0563 plus 0.18771. And the last one should give you 0.28157. So altogether these give you 0.526. And as below, the next question will ask you less than. So now we're looking for the probability that x is less than 2. This does not equal 2. It's strictly less than. So you only look for your 0 and your 1. And from our previous equation, you could add that up. And we have 0.0244. Thank you. Example, but probably our most failed one is where they say at least, and they give you a very low number. In other words, x should be greater than or equals to 2. Now, there's one way you could go about this, but a nice way to remember this is that jot down all your numbers if you can't visualize it. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now we know they're looking for x greater than 2. So it'll include all those numbers that are greater than 2. So 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so one thing we know about binomial distribution is that all your possibilities should give you a total of 100%. That only makes sense. So we can use this property to our advantage. Instead of saying this one, we can just say 1 minus the probability that x is less than 2. And we know from the previous equation that this is equals to 0.0244. And that should give you a total of 0.9756. So that pretty much wraps up binomial distribution. And please subscribe to my channel. And in the next videos, we'll be discussing the Poisson distribution.